Well, my name's Tom Barrett. This is part of a much bigger presentation, so if anybody would like more information, give me a holler, copy down the email address. But I wanted to start off first with water, water everywhere. You probably remember the rhyme of the Ancient Mariner from back when you were in school. And sometimes I feel like the Ancient Mariner. In its report card for America's infrastructure, the American Society of Civil Engineers gives our nation's dams a grade of D. It gives our wastewater, drinking water, stormwater systems a D-. This is the lowest grade of any infrastructure category. And back when you were in school, receiving a D or a D-, at least for me, got me in trouble with mom and dad. But in this situation, when it comes to water, the next lowest grade is an F, and an F is unacceptable. The U.S. Department of Environmental Protection Agency states that public health and environmental gains achieved since the passage of the Clean Water Act are rapidly being reversed due to our crumbling infrastructure. New York Mayor Bloomberg, commenting on the current state of our nation's infrastructure, says, "We underinvested and we invested badly. Clearly, we need to invest more to upgrade and maintain our failing water infrastructure, but we need to invest more wisely, too. We'll make a terrible mistake if we simply rebuild 19th and 20th century water infrastructure systems that are costly and inflexible." So today there's an opportunity, and I believe a really big opportunity, to take a 21st century approach that integrates gray infrastructure with green infrastructure, creating community safety and security. So how much water is there, and why choose green infrastructure? When I started to first get involved with this, and it's been over 10 years now, there's a lot of water available. And when we look at what we currently do with the water, there's a lot of opportunities to do it better. And the best way is to do it the way that nature works. Rivers, streams, wetlands, floodplains, and forests provide a suite of critical services that help to clean and polish our water, provide flood protection, and can be viewed as essential and effective components of our water infrastructure. To give you an example, New York City has great quality tap water, and it's because they go upstream of the Hudson in the Catskill reservoirs and use the water from up there. Recently, they invested about $600 million in the Catskills Land Protection and Restoration Project. This did the job of $6 billion in capital costs to construct a water filtration plant, as well as saving $200 to $300 million in annual operating and maintenance costs. We can't waste money. With the current economy, it's impossible to waste money, but spending money wisely and investing in multi-purpose solutions can lower cost and provide greater benefits. So when I started to work on this, probably the easiest source of alternate source of water is going to be rainfall. And I'm going to talk about Chicago, and the reason why I talk about Chicago water is because Chicago is pretty much in the middle of the country, and it's in the middle of the rainfall spectrum. Chicago gets between 30 and 33 inches of rainfall a year. Raleigh, Charlotte gets about 46. Orlando will get 50, 55 inches. New York will get about 45. Los Angeles gets about 17. The desert will get about 19. So Chicago puts us somewhere in the middle, and in all areas of the country, about 1/4 of an inch of rainfall on a 2,500 square foot roof will generate about 400 gallons of water in a typical rain event. One of the problems that we currently face today when we're looking at rainwater harvesting is people are looking at it as a way to save water. And so when the rain event occurs, they collect their 400, 500, 6 gallons of water, which everybody that does rainwater harvesting is surprised at how quickly the water is collected and how much water they have. And then they hold on to it. But what you'll see in a few minutes is that holding on to this rainwater is not necessarily a good thing to do. So to give you an idea, a little bit bigger idea, just how much water occurs in Chicago, in a typical 2,500 square foot roof, they can collect about 56,000 gallons of water a year. If we take a look at the entire property, they can collect about 250,000 gallons of water a year. When we start to look at larger 3-acre commercial property, almost 3 million gallons of water is generated every single year. And on a city block in Chicago, and Chicago is not a typical city block, but they actually use a double block system, there's almost 10 million gallons of water a year generated on a city block. So in Chicago, we have plenty of water. And in many cities, we have plenty of water. In fact, in Chicago, as you'll see, we have a little bit too much water. Almost 5 to 10 million gallons of water a year can be collected off a city block. There's really no higher quality source of water available to us than rainwater. Now, this is not storm water, but the rainwater, we don't have to treat it. It's great. It's clean. It's good water to be used, and we can effectively collect it from roofs and impermeable surfaces, and it can represent a substantial source of water for inside and outside buildings and homes. So how do we collect it? Today we can use cisterns, and here's a picture of an above-ground cistern. There's below-ground cisterns. It's not very difficult to put a screen on top of the gutters, not difficult at all to get a stormwater or downspout diverter and put the water into cisterns. There's also condensation. There's several sources of water, and every time we've worked on a commercial property, I've been shocked at how much water we can develop. For residential condensation, which is the water that comes off of our air conditioners, based upon humidity, the manufacturer, it varies from place to place and from location to location. We can generate 8 to 15 gallons of water per day from a small residential system. 60 to 100 per week, almost 500 gallons of water per month can come off of a residential system. What I really like about residential condensation collection, or any condensation collection, is the condensation production occurs simultaneously with the need for plants to have water. As our heat, humidity goes up, plants need more water. Usually hot, dry spells, plants need more water. And so this system here has the ability to collect the water, utilize it on the plants. And what happened up in Sacramento, Brinkerhoff and Associates worked on a project, 6-story office building out in the desert. And this building was generating about 3,000 gallons of water a day just off condensation. And what they did with this particular property was they took the condensation and they sized a landscape appropriate to use that much water. And that's the point of my entire presentation. How much water do we get on site? How do we utilize that water in a way that's effective and not put it into the stormwater system or the sewer water system? So a commercial project, it's not at all unusual to see 15 gallons of water an hour produced. Almost 10,000 gallons of water a month can come out of a big box project. So it's not hard to get. And today what we normally do with it is we send it down the sewer system, the storm drain, or we let it drip out onto the parking lot to evaporate. There isn't any reason why we can't use this water. So when I put all this together, and this slide here is one of the key pieces of the entire projects that we work on, what you'll notice is we have a cistern. This time it happens to be a below-grade cistern. This cistern collects all of the storm water or rainwater, condensate water, and there's a series of 4 sensors in this cistern. The top sensor senses when the cistern is full. So when the cistern is full, it will delay about 18 hours, and it probably is full because of a rain event. It'll delay about 18 hours and then start to irrigate, force the water out of the system to mitigate the stormwater issues. The other sensors are in there to say we've got this much water collected, don't irrigate unless the system needs it. So it's a smart sensor. And then at the very bottom we have a sensor in there that says we don't have enough water, and we can use that sensor there to either fill with potable water if we want to, or there's a device that's available today that will sense that we have run out of rainwater if we're using it for any kind of domestic water situations such as flushing toilets, and allow it to use potable water. So there's a lot going on in this one diagram, but we can pull the whole thing together and literally create a facility with zero stormwater runoff. That helps a tremendous amount with our pollution issues. Because what this is really all about is stormwater mitigation. So there's rainwater and then that becomes stormwater, and that stormwater we've treated in the past as a disposal issue. We try to get rid of it. We rapidly collect it, we condense it, we pipe it, and we move it into our lakes, streams, rivers, and local waterways. In a naturally vegetated environment, deciduous hardwood forest, which is what we would have here in the Midwest, 92 to 98% of the water would have been returned into the environment. And some of you, if there's anybody from down in Florida, you're starting to experience some problems right now because we've done such a good job of getting our stormwater moved off of our impermeable surfaces and out into the local waterways that we're seeing a depletion in the aquifers. We're having sinkholes, and last year the city of Tampa actually restricted outdoor water use pretty severely. So today we rapidly collect it, we pipe it, and we move it into our local waterways. And in a natural fashion, 90 to 92% of our stormwater would have gone back into the environment. 8% would go into the environment as evapotranspiration. The rest of it goes through the soil, and the soil creates a natural cleansing process. This image that you're seeing right here is a stormwater overflow pipe in the city of Indianapolis. In the last 20 years, our population has grown about 8%. Our impermeable surface areas have increased about 40%. The problem that we have is in many communities, we combine our stormwater with our wastewater systems, and we overflow our sewage systems. For me, it seemed rather redundant to take rainwater and cleanse it like wastewater. But more importantly, one of the bigger problems that we have in many communities, as little as 1/4 of an inch of rainfall will cause our sewer systems to overflow. And since it's a first in, first out process, the sewer water will go out into our local waterways untreated. Here in Indianapolis, the second largest polluter in the state is the city of Indianapolis, because as little as 1/4 of an inch of rainfall causes raw sewage to be dumped into our local waterways. And there's an opportunity here. There's a huge opportunity that we can start to work with our stormwater as a valuable resource, because it is. The city of Indianapolis is planning to spend about $1.8 billion on a deep tunnel project. The city of Milwaukee just spent $3 billion on a deep tunnel project. A couple of problems that occur with deep tunnel projects: they're designed to hold on to the sewer water until the stormwater passes through, but they're not dynamic. They can't be sized appropriate to increases in impermeable surfaces or decreases in impermeable surfaces. They're very expensive, and in many times they go over budget. There's an untapped reservoir here that we have with water, and we can't waste money on it. It means investing in a multi-purpose solution that helps to lower our cost. The city of Indianapolis found that through a downspout disconnection system, they were able to reduce one of their sewer pipes from 30 inches to 26 inches, and they're saving about $300 million. In this particular building, this building was designed for zero stormwater runoff. All of the water that falls on the impermeable surfaces are designed to be captured in rain gardens, through green roofs, through irrigation systems, and utilized in the landscape. What I really like about this solution here is that our landscapes move away from being strictly an aesthetic function into a very valuable resource utilized by the property. It becomes part of the building management facilities. So there's a lot of technical things that have to happen to make this work. We have to match the percolation rate of the soil to this amount of water that we're generating from the property, from the amount of hardscapes, but it's entirely possible and usually less expensive to design a building for zero stormwater runoff. In parking islands, typically what we're looking at doing is, instead of having those small 3-foot bumper strips where we'll plant trees that seem to pass away in about 7 years, we increase the size of those planting strips. We put more shade down. We get more trees in, we get more plants in, and in many cases, if you're familiar with the LEED rating system, we can achieve 12 LEED points between stormwater management, irrigation system design, and shade. So there's lots of opportunities. There's lots of opportunities to do things differently here. So when we think about it, there's no higher quality of water to us than rainwater. And unlike the water that's captured in dams and requires some extensive treatment processes, we can collect the rainwater, we can collect it off our roofs, we can store it appropriately, and we can create a sustainable resource that mimics the way nature does water. By using rainwater for toilet flushing, by using rainwater for laundry and for garden, we can typically reduce the amount of water in households by 70%. And if rainwater is used for hot water systems, it can be as high as 85%. And so we have an opportunity. We can enhance our community. Traditional infrastructure is not designed to handle the increased floods and droughts that are coming with global warming. We need something that's dynamic so we can take a more modern approach to protecting public health and our quality of life. Green solutions give communities the security and flexibility they need. In Napa, California, they solved their flooding problems by choosing to restore the Napa River's natural channel. Rather than lining the river with concrete, they planted trees and they protected 27 homes and prevented $26 million in flood damage. And it's created new parks, new open spaces, and new habitats. So in my opinion, we're at a crossroads. We're at a crossroads in how we view and manage our water. Traditional water infrastructure is guaranteed to play a big role, but it's static. It solves only a single problem. It requires a lot of money to build and maintain. So what I see is a transformation from the old gray infrastructure to a combination green infrastructure with gray infrastructure, creating a more natural environment. And that's it. I'm done. I appreciate the time to talk with all of you. If anybody has any questions, please give me a holler.